Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular looking at how we can solve trig equations. So if you find this video helpful, consider hitting the like button and subscribing, and let's go. So, solving trig equations is no different than solving any other sort of equation. You have some variable your goal is to isolate, get by itself, to then solve for it. Now, solving trig equations is kind of like when you solve logarithmic equations or exponential equations. There's some sort of function that's in the way of that variable you want to isolate. So what you typically want to do is isolate that function first. So in our case, the first key tip I'm going to give for us is isolating trig functions. Once we do that, I'm going to encourage us to lean into drawing pictures to visualize what we're actually finding. And then for more complicated situations, use substitution to make the problem look easier. So let's look at three different types of equations. So I'm going to say basic, kind of intermediate difficulty, and then hard. So a basic equation might be 2 sine of theta plus 1 is equal to 0. Using that first tip, we want to get at and solve for theta, so we're going to isolate sine first. To do that, you can subtract your 1 over the equal sign to the right, and then divide both sides by 2. And that will leave you with the following. From here, we want to know what picture can help you visualize this. Now, sine and cosine, I'm going to encourage you to visualize things with the unit circle. Because on the unit circle, sine is the y coordinate and cosine is the x coordinate of points on it. So I'm going to draw a unit circle, and I'm going to lean into the fact that I know that y coordinates are sine. So I'm going to draw a line on my unit circle at y is equal to -1/2. Once we've done this, we can visualize that within one period of sine. So one time going around the circle, I'm going to have two different solutions that are going to give me -1/2. And luckily, -1/2 is a nice point on the unit circle for us. So we know the angles that are going to put us here. One of these angles, which I could write as maybe theta 1, I can express that as 7 pi over 6. The other angle I could have, the easiest version that I'm going to pick out is theta 2 is equal to negative pi over 6. So using those two specific angles that put me at those locations, I can write the following equations that will give me all possible solutions. I can have theta is equal to 7 pi over 6, so I picked one specific value. And then every time I go around the circle, again, in either direction, I'll pick up more solutions. So I add that 2 pi n. Or, and same thing with my specific value of negative pi over 6. I add 2 pi n to that, because anytime I go around the circle fully in either direction, I'll end back up at that point. So this will give me all possible solutions that are going to be coterminal to net that angle of negative pi over 6. And again, I'm specifying n is for any integer. It's integer multiples of 2 pi. So this would be an example of a basic equation. Now, you could do this same basic equation idea with cosine instead of sine. So you would isolate cosine first. Use the fact that cosine is the x values on the unit circle. And say we're going to draw on our unit circle the equation x is equal to root 3 over 2. Again, know that these are nice points on the unit circle. Values of root 3 over 2 are nice. We would have our 2 points listed there. And now, because they're nice points, we know angles that put us there. Our first angle that's going to be the easiest is theta 1, which I'm going to call pi over 6. Or I could have an angle theta 2 of negative pi over 6. And then you can write equations just like last time. All the angles that are going to be coterminal to pi over 6 are going to be pi over 6 plus 2 pi n, so integer multiples of 2 pi. And then again, all the angles that are going to be coterminal to negative pi over 6 are going to be, and of course, negative pi over 6 plus 2 pi n. And of course, you always need to specify with n any integer. So you definitely want to make sure the reader knows that n is just integer multiples of 2 pi. So this is, I'd say, the most basic forms we have. These are nice values on the unit circle. Let's look at something that's a little bit more difficult. So let's look at cosine of theta is equal to negative 3 over 5. Again, you start off by isolating and using the fact that cosine is the x coordinate on the unit circle. The only issue now is negative 3/5 is not a nice value we immediately know the angle for on the unit circle. But that's fine. This is where some inverse trig is going to come in handy. Now, you should remember that if I want to find the angle that says is what gives me a value of negative 3/5 for cosine, if I use my inverse trig and say what is cosine inverse of negative 3/5, this is going to give me back an angle between 0 and pi, because that's where the principal domain is when you construct your inverse trig function. So on our unit circle, what inverse cosine of negative 3/5 will tell us is this angle here of theta 1. So when you plug that into your calculator, you get that that is roughly about 2.214. Now, that's fine. You can then use symmetries to find a second angle. So an angle theta 2. In this case, theta 2, if I draw it like this, is just going to be negative what theta 1 is. So theta 2 is going to be equal to negative cosine inverse of negative 3/5, or negative 2.214 approximately. But once you've found these two specific answers within one period of the function, it's just adding integer multiples of those values. So our final solution would be about 2.214 plus 2 pi n and negative 2.214 plus 2 pi n, where n is any integer multiple. So it's just a little bit more work. You have to use a little bit of your knowledge of inverse trig. Now, you don't always have to stick to sine or cosine. We can do problems with tangent as well. So tangent is similar, except I'm going to recommend you don't draw pictures of the unit circle this time. We'll draw a picture of the part of tangent you restricted to when you create the principal domain of for the inverse function. So we're going to still start by isolating tangent. But like I said, we're just going to look at the principal domain that we used when we create our inverse function. So when we look at this one band of our picture for the graph of just tangent, we can ask ourselves, when is y equal to this value? When is y equal to negative 8? So y is equal to negative 8 is just going to happen in one spot within that strip. So that means when we plug into our calculators tangent inverse of negative 8, we just end up with the theta value that's going to correspond to that one specific value, which I've indicated here on the graph. So now when you go to write your full solution, instead of having two equations, you're only going to have one. So theta is equal to approximately negative 1.446, but this time plus pi n, because tangent's a pi periodic function. We're just looking for this corresponding value in each successive strip, so shifting a pi over each time. And of course with n any integer. So these are what I would consider are moderately difficult problems. Now, the most difficult I would give any problem to my students would be something along this line, the lines here, with sine, cosine, or tangent, where I've messed with what I've plugged inside of sine. So here's where I'd recommend using this third tip. Use substitution. And what I'm going to substitute in particular is I'm just going to let this whole part inside be equal to u. So when I write this, I just think of this equation as solving the following, which is a much more simple equation to solve. This is like one of the moderate equations on the last page. So I'd isolate sine, draw my picture using the fact that sine is the y coordinate on the unit circle to end up with the following. Now, in this picture, again, I have a u1 and u2. There's not nice values here, so I'm going to have to use inverse trig. When you restricted sine to be able to create its inverse function, the principal domain we restricted to was negative pi over 2 to pi over 2. So that means when I plug into my calculator or sine inverse of 1/5, I'm going to get the angle that'll put me at that u1 value, because that's between negative pi over 2 and pi over 2. And that's going to give me approximately 0.201. And likewise, if I'm looking for u2, based on how the symmetries of the unit circle work, I can say that this is just not quite pi. I need to subtract off that sine inverse of 1/5 from pi to get a value of approximately 2.940. And in the previous problem, since we're just interested in integer multiples of these values of u to give us solutions, we would write the following and we'd be done. But we made a substitution at the beginning. We don't want to solve for u. We want to solve for theta. So what this equation can be rewritten to say is the following. I've just replaced u with that pi over 3 times theta plus 1. Now we can solve both of these equations for theta. To begin with, you can multiply both sides by 3 over pi to get rid of that fraction. So we'd end up with the following. Now, in the end, I usually get rid of my pi's in these first terms here. I'll only leave pi's in the part where that plus 6n part if they were going to exist there. But I'm going to wait to get rid of the pi's and then approximate one more time until I've subtracted the 1 off of both sides, because the only thing I'm subtracting 1 off of is these first two values here. I'm not subtracting the 1 off of my period shift. So I've gotten, again, an approximation. Theta is approximately negative 0.808 plus 6n, and approximately 1.378 plus 6n, with n is any integer. And this is going to be my final solution, or my solutions to this much more complicated equation. So, but you don't need to do this with substitution. I just find it easier to, in this first half of the problem, imagine it like one of our easier problems before. So, I hope you found this video helpful, and if you did, consider hitting the like button, and have an awesome day.